In this example, you're asked to solve the equation cosine of 2x plus 3 cosine x plus 2 equals 0, where x is between 0 and 2 pi radians. So the first big thing to notice here is that this equation involves trig functions of different angles. Here's cosine of 2x, and here's cosine of x. So unless x is 0, then cosine of 2x and cosine of x will be different things, cosine of 10 and cosine of 20, let's say. So the first thing would be to write it in terms of a trig function of a single angle. And the nice thing about 2x is you can apply one of the double angle formulas. So, cosine of 2x, double angle formula for cosine actually has 3 versions. I think of it as the primary version is cosine squared minus sine squared. Cosine of 2x is equal to cosine squared minus sine squared. You get 2 other versions of this equation when you do substitutions from your sine squared x plus cosine squared x equals 1 identity. So if you rearrange that, you could turn cosine squared into 1 minus sine squared. And then this equation becomes cosine of 2x equals 1 minus sine squared x minus sine squared x. So that's equal to 1 minus 2 sine squared x. Okay, so there's one alternate version for cosine of 2x. You could do a similar substitution. You could turn the sine squared into 1 minus cosine squared. That's a minus right there. And then you, when you distribute, my little pointer, when you distribute this negative right here, you'd have negative 1, but then you'd have positive cosine squared x. So you'd end up with 2 cosine squareds minus 1. And that's the other version. So you've got 3 choices. When you see cosine of 2x, you can choose any one of those 3 options. So let me rewrite the original equation. So we've got cosine of 2x plus 3 cosine x plus 2 equals 0. So we'd like to write this in terms of a single trig function of a single angle. Since you've got cosine of x right here, the version that only involves cosine of x, so this version number 3 down here would be the best one to substitute in this problem. If this were a plus 3 sine x, then it would be best to substitute this expression, 1 minus 2 sine squared. But with the cosine of x here, we're going to use this one. So I'm going to turn the cosine of 2x into 2 cosine squared, minus 1. Okay, and then leave the rest as is. Okay, and then combine like terms. So 2 cosine squared x plus 3 cosine x. And then we've got negative 1 plus 2. So that'll give us positive 1. And then factor. So I'm going to go ahead and rather than do the whole u equals cosine of x thing, I'm going to try to just factor it as is. 2 cosine squared can only factor, if we're going to use integers, as 2 cosine times 1 cosine to get the 2 cosine squared. And the positive 1, well, the only way to factor that with integers is positive 1 and positive 1. Well, or negative 1 and negative 1. But since the sign in the middle here is positive, you know that these need to both be positive. It never hurts to double check, so just to multiply that out real quick. 2 cosine squared x. The outside would give you plus 2 cosine x. Inside gives you plus 1 cosine x, so that'll be your plus 3 cosine x plus 1. So this looks good. And then you'd set each factor equal to 0, which I might actually, squeeze onto this page. So 2 cosine x plus 1 equals 0. If you isolate the cosine x in that, you'll have, this is a 1, negative 1/2, because you'd move the 1 over, it become negative 1, and divide by 2. Over here, if you set cosine x plus 1 equal to 0, then cosine x equals -1 when you move that over. Okay. So I'll rewrite those equations on this side. Cosine of x equals -1/2 or cosine x equals -1. Okay, and so once you've got the trig function by itself, then you can go to the unit circle to find the angles that we need. Notice that now this equation involves only cosine of x, so we don't have to do the whole plus 360 degrees times n thing and then generate solutions by substituting n equals 1 and n equals 2. If it's just cosine of x, then we can just get our solutions directly off of the unit circle. So we want to know when is cosine -1/2. Remember that cosine is the x coordinate, so there's a solution here and there's a solution here. And the problem said x is between 0 and 2 pi, so we're going to use radians here. So here's two solutions, 2 pi over 3 from that quadrant 2 solution, and 4 pi over 3 from that quadrant 3 solution. Okay, and then cosine x equals -1, that's right here, when x equals pi. And so there's your complete solution set. Like I said, since we rewrote this in terms of just cosine of x, you don't have to mess with looking for those extra solutions that sneak in because the period's changed. It's just the values directly off of the unit circle. If this were cosine of 2x, then you'd have to, if we had cosine of 2x equals -1, then we'd have to write out the plus pi n or plus 360n and then substitute n equals 1 and so on.